With problem number 3, we're given the graph of f, and it's shown on the interval from 0 to 3. So that's 3 right there. Which of the following has the smallest value? Our first option is the integral from 1 to 3 of f of x dx. Okay, so this is equal to the area under the curve. So that is probably going to be right smack dab in the middle, because I'm guessing we're going to have some lower estimates and some upper estimates. Let's verify that. Part B is a left Riemann sum with 4 subintervals of equal length. All right, from 1 to 3. So we're interested only in this zone right there. Now, if we're doing a left Riemann sum, all right, a left Riemann sum is going to be a situation like this, where the rectangles are above the curve because the function is decreasing. So this is going to be an overestimate. Now, yes, all right. We know that the integral from 1 to 3 is the actual area under the curve, so this one's definitely out because an overestimate will be larger than the actual area, and we are looking for the smallest value. Now, our right Riemann sum, conversely, will be an underestimate because we have a situation like that, and the rectangles for the right are going to be too small. Okay. Next up, we have a midpoint Riemann sum. We know that midpoint Riemann sums are extremely accurate. They'll be more accurate than a right Riemann sum because some will be above and some will be below. And so this little extra right here gets canceled out by that little extra right there. So a midpoint is going to be larger than a right Riemann sum, so the midpoint is out. And now we get the trapezoid sum. The trapezoid sum deals with the concavity. If I make a big trapezoid right here, okay, I can see that the trapezoid is definitely smaller than the actual area. So the trapezoid is an underestimate as well. So we know that a right Riemann sum is an under, and we know that a trapezoid is an under. All right, this is the actual area, so that's out as well. The answer is either going to be C or E. Now, we know that a trapezoid sum is more accurate than a right sum, so that's one way of knowing that the answer is going to be C. The other way is just by actually looking at it. And again, I've drawn all over the picture right here, but we know that the right Riemann sum, because we're doing 4 subintervals for each of them. So the right Riemann sum has a situation like this one right here, whereas the trapezoid, if we make the trapezoid in that situation, we can see that the trapezoid is much more accurate, much closer to the curve. It's not missing as much area as the right Riemann sum is. So our answer is the right Riemann sum. Underneath that, we have the table with select values for f, and if f is increasing, and I mentioned that, so that must be important, over the interval from 0 to 3, which of the following could be the value from 0 to 3 of f of x dx? All right, well, we have 5 options here. We know that if the function is increasing, all right, then a left sum is going to be too small, and a right sum is going to be too large. So if we can find the left sum and the right sum, then maybe we can pick an answer in between. So let's go for the left sum for starters. All right. So the left sum, in every single case, our delta x is going to be a half. Now with the left sum, we're going to use the 0, 4, 10, 18, 28, 40, but not the 54. So our left sum is going to be 1/2 times 4 plus 10 plus 18 plus 28 plus 40, but not the 54. And technically we added the 0 as well. There is a 0 right there, I just didn't write it. Okay. So if this is our left. All right, and so 4 plus 10 is 14, plus 18 is 32, 32 plus 28 is 60, 60 plus 40 is 100, so the left is going to be half of 100, or 50. All right, now we see that 50 is one of our answers, but we know that 50 is too small because a left sum is going to be an underestimate. Now let's do the right sum. So with the right sum, right, and again, delta x is always a half, so we have a half times, we're going to use the 4 all the way through the 54, but we don't use the 0. All All right, so we'll have 4 plus 10 plus 18 plus 28 plus 40 plus 54. And if we add all that up, we're going to get an answer of 1/2 times 154. And half of 154 is 77. Now that's too big, so it's kind of like Goldilocks and the Three Bears. The 50 is too small. The 77 is too large, which means the 62 is the one that could be the value of our definite interval.